welcome to biology online class from the Krishna High School. Last class we have discussed about the 4 stages in the heartbeat. Now we will discuss how the heart is producing the lub and dub sound during the heartbeat. During the heartbeat, heart is producing the 2 kinds of the sounds, lub sound and dub sound. Yes. You know, when the heart is producing this lub and dub sound, look here. Yes. This is the heart. Look here, this is the pulmonary wall. Yes. This one is the tricuspid wall. Yes. Systemic wall. Yes. This one is the bicuspid wall. Yes. Right auricle, left auricle, right ventricle, left ventricle. Look here. So, heart is producing lub sound during the ventricular systole and ventricular diastole. Yes. Look here. When the ventricles are contracted, right ventricle pumps blood into pulmonary artery, left ventricle pumps blood into systemic artery. At the same time, there will be chance to flow blood from right ventricle to right auricle, left ventricle to left auricle. To preventing this backward flow of the blood, this tricuspid valve and bicuspid valves are closed, producing the lub sound during the ventricular systole. Yes. During the ventricular systole. During the ventricular systole. Tricuspid valve. Tricuspid valve and bicuspid valve. Tricuspid valve and bicuspid valve are closed, producing the lub sound. During the ventricular systole, tricuspid valve and bicuspid valve, both these valves are closed, producing the lub sound. Yes, so during the heartbeat, when the heart is producing lub sound. Yes. During the ventricular diastole, this pulmonary valve and the systemic valves are closed. When the ventricles are relaxed, then what will happen? There will be chance to flow the backward flow of the blood. Means from the systemic artery to left ventricle, pulmonary artery to right ventricle. That's why during the ventricular diastole, yes, during the ventricular diastole, yes, pulmonary valve and systemic valve. Yes, pulmonary valve and systemic valves are closed. Look here. During the ventricular diastole, this pulmonary valve and the systemic valves are closed, producing the dub sound. In this way, heart is producing the lub sound and dub sound. When the heart is producing the lub sound, when the tricuspid valve and the bicuspid valves are closed during the ventricular systole, producing the lub sound. Heart is producing dub sound during the ventricular diastole. By closing the pulmonary valve and systemic valve. In this way, heart is producing the lub sound and dub sound during the heartbeat. You know, the total time period required for the completion of this cardiac cycle is 0.8 seconds. seconds. The time being required for the heart rate or the cardiac cycle is 0.80 seconds. In which broadly 3 stages, auricular systole. This stage will complete 0.11 to 0.14 seconds. Yes, the time is required for the auricular systole 0.11 to 0.14 seconds. The time period for the ventricular systole is 0.27 to 0.35 seconds. And the remaining time is the joint diastole. Auricular systole, it will complete within 0.11 to 0.14 seconds. And the ventricular systole is completed within the 0.27 to 0.35 seconds. The total time period is required for the heartbeat is it will be 0.8 seconds. Yes, this rate of heartbeat also, it is not uniform in all animals. It is different in the different animals. Yes. Yes, look at here. Yes, heartbeat and body weight and the heart rate in different animals. Yes. Yes, animal name. Yes. Body weight in cases. Yes. Next, heart rate. Yes. In cases. Last one is the heart rate. Yes. Heart rate in minute. Heart rate in the minute. Look at here. Yes. Blue whale. It is the largest animal on this earth planet, which is weighed about 1,50,000 kgs. Means 1,50,000. That means 150 metric tons. Yes, and the heart weight will be 750 kgs. 750 kgs. Heart weight will be 750 kgs. But the heart rate will be 7 times per minute. Blue whale body weight will be 1,50,000 kgs. Heart weight will be 750 kgs. Heart rate will be 7 times per minute. Yes. Next one is the elephant. Yes. Body weight will be 3,000 kgs. The body weight of elephant is 3,000 kgs. And the heart rate will be 12 to 21 kgs. The heart rate in the elephant is 12 to 21 kgs. Heart rate will be 46 times per minute. And next one is in a human being. Yes, in man. Yes. Body weight will be 60 to 70 kgs. Yes, we should take the approximate normal average weight 60 to 70 kgs. Heart weight will be 300 grams. 300 grams. And the heart rate will be 76 times per minute. Yes. And the next one is the coiled bird. Yes. Coiled bird. And the body weight will be 8 grams. Yes. Body weight will be 8 grams. Heart weight will be 0.15 grams. Heart rate will be 1200 times. If you will observe this table, yes, observe this table. What do you understand about this table? Look at here. From blue whale to coiled bird, gradually body weight is decreases and the heart rate is decreases and the heartbeat is increases. Suppose they will ask questions like this by giving the table. Why the rate of heartbeat will be very less in the blue whale? Generally, blue whale is large in size and it has lots of mass, large weight. Heart weight also will be 750 kgs. Such a large heart is producing the contraction and relaxation, which it takes place more time period. This is the general reason. If you want to say scientifically, BMR, basal metabolic rate. You know what is the metabolic rate? The rate at which a compound is synthesized or degraded in the body of animal is called a metabolic rate. Means what rate of the compound is produced or used in our body, that is called metabolic rate. Yes. If this metabolic rate is found after fasting the overnight, that is called as a basal metabolic rate. What is the basal metabolic rate? If the metabolic rate is determined after fasting the overnight, means whole night food is not given. Next day morning, we will measure the metabolic rate by using the spirometer. That is called as a BMR, basal metabolic rate. So, according to this BMR, in the large animals, BMR is less. In the small animals, BMR is a maximum. Why? Smaller animals, they have the more body surface, more surface area. Suppose you will take the two potatoes with equal size. You can cut one potato into small slices. Another one is you won't cut, and all these are exposed to sunlight. You know which potato can rise early? Potato which is made slices only dries early than the whole potato, because the whole potato has the less surface area, but potato slices have the more surface area. That's why they will dry early. Same principle is applicable here also. In the larger animal, body surface will be less. That's why BMR is less. BMR is less in the larger animals, small in the larger animals. Yes. BMR, basal metabolic rate, is less in the larger animals. That's why in the blue whale heartbeat will be less, only 7 times per minute. In the coiled bird, this heartbeat will be 1200 times per minute, because coiled bird is very small in size. According to this BMR, the basal metabolic rate BMR is more than the small animals. Coiled is the smallest bird, very small bird. That's why it has the maximum heartbeat. So that is the reason for the heartbeat in the different animals. Yes. Next we will discuss about that blood circuits. Yes. You know what is the blood circuit? Let us go discussing about that blood circuit. Yes. You know what is the blood circuit? The path in which blood is flows through the blood vessels is called as a blood circuit. In the human body, blood is flows through the blood vessels in a particular path. That path of flow of blood in the blood vessels is called as a blood circuit. Yes. What is the blood circuit? The path in which blood flows through the blood vessels is called as a blood circuit. In higher animals, two types of blood circulatory systems. Yes, two types of blood circuits. One is the single circulatory system, and the second one is the double circulatory system. You know what is the single circulatory system? Yes, the circulatory system in which blood flows through the heart only once. The circulatory system in which blood flows through the heart. Yes, through the heart only once. Yes, only once. The circulatory system in which blood flows through the heart only once is called a single circulatory system. Yes, look here. Example, fishes. Yes, in fishes. Yes, heart, gills, body parts. Yes. Look here. Deoxygenated blood from all body parts is collected. Deoxygenated blood from all body parts is collected in the heart by the capillaries. Then the heart pumps blood into the gills. What about blood? Deoxygenated blood only pumped. In gills, blood is oxygenated. After the oxygenation, blood will flows from gills to body parts directly. It won't return to the heart. In which through the heart, blood is flows only once. Heart to body parts, body part to gills. Not heart, not returns to heart. Deoxygenated blood from all body parts is collected to heart. Heart pumps blood to gills. So there is an exchange of or flow of blood between the heart and organs. That's why it is called as a single circulatory system. The circulatory system in which blood flows through the heart only once is called as a single circulatory system. Yes, example for this fishes. Fishes are the example for the single circulatory system, in which heart is called as a branchial heart. The heart in the fishes is called as a branchial heart. The heart in the single circulatory system is called as a branchial heart. Why it is called as a branchial heart? It pumps blood to gills. What is the branchial heart? Heart that pumps blood to gills is called as a branchial heart. Heart that pumps blood to gills is called as a branchial heart. You will see this type of branchial heart in the fishes. Example for the single circulatory system are the fishes. What is a single circulatory system? The circulatory system in which heart pumps blood into. Yes, the circulatory system in which blood is flows through the heart only once. That is called as a single circulatory system. Yes. Now we will discuss about that double circulatory system. Yes, double circulatory system. You know what is the double circulatory system? The circulatory system in which blood is flows through the heart twice. The circulatory system in which blood flows through the heart twice. Once between the heart and lungs, second between the heart and body parts. Yes. Yes, look here. The circulatory system in which blood is flows through the heart twice, once between the heart to lungs, lungs to heart. That is the one circuit. And the second one between heart to body parts, body part to heart. In this way, blood is flows through the heart twice, once between the heart and lungs, second one between the heart and body parts. What is a double circuit circulatory system? The circulatory system in which blood is flows through the heart twice, once between the heart and lungs, second one between heart and body parts. This is called as a double circulatory system. Yes. In which pulmonary artery, which takes the major role in the flow of blood between the heart and lungs. That's why it is called as a pulmonary circuit. Yes. Pulmonary circuit. Yes. And the second circuit is the systemic circuit. What is the systemic circuit? The path of flow of blood between the heart and body parts, in which systemic artery, yes, look here, in which systemic artery, it takes a major role in the flow of blood between the heart and body parts. In the pulmonary, there are the two blood circuits in the double circulatory system. One is the pulmonary circuit, second one is the systemic circuit. So what is the pulmonary circuit? Flow of blood between the heart and lungs is called a pulmonary circuit, in which pulmonary artery takes the major role. Second one is the systemic circuit. The path of flow of blood between the heart and the body parts is called a systemic circuit, in which a systemic artery takes the major role. That's why that is called as a systemic circuit. Yes. So there are the different circuits. Next, lymphatic system. Yes, up to this blood circulatory system is over. In the next class, next session, we will discuss about that lymphatic system.